Hey, learner. Ever feel like your brain's a computer hitting 100% CPU, just trying to keep up with the world? Today, we're diving into how our brains actually manage that information overload and the surprising stars of the show.
It turns out we've been giving the spotlight to the wrong brain cells this whole time.
Oh.
We always hear about those chatty, excitatory neurons firing off signals left and right. But research from the tuning of tuning
Okay.
reveals that inhibitory neurons, the quieter ones, are the real heroes of efficient information processing.
Okay, hold on. Less is more when it comes to brain power. That seems kind of counterintuitive. How does that even work?
Think of it this way. Imagine you're trying to have a conversation at a crowded party.
Right.
The excitatory neurons are like everyone talking at once, creating a lot of noise. But the inhibitory neurons, they're like those noise-canceling headphones, filtering out the distractions so you can focus on what's important.
So it's not just about the amount of activity, but the quality. That makes sense. I guess our brains would be a jumbled mess if everything was always firing off at once.
Exactly. And this research, focusing on the mouse barrel cortex, the part dealing with their whiskers, used a really clever technique to figure this out. They essentially simulated a constant stream of information, like what our brains experience in the real world, and measured how well different neuron types handled it.
So they basically put these neurons through a stress test to see who cracked under pressure. What did they discover about these inhibitory neuron superstars?
Well, it turns out our brains have a built-in system for managing this information overload, something called a dynamic threshold. Imagine your email inbox. You don't want to see every single message.
Right.
So you set up filters to prioritize the important stuff and block out the spam.
Okay, so our brains have spam filters. Now, that's something I can relate to. But how does this dynamic threshold actually work? Are our neurons constantly adjusting what they consider junk information?
That's exactly it. It's like they're learning as they go, becoming more and more efficient at filtering out the noise. And here's the fascinating part. The research found that there's a sweet spot for this adaptation.
Okay.
Too much filtering, and the neuron becomes kind of unresponsive, missing out on potentially important information.
Right.
Too little, and it's overwhelmed, like an inbox exploding with spam.
So it's all about finding that just right balance, kind of like Goldilocks and her porridge. Our brains are pickier than we thought, but if every neuron is fine-tuning itself, does that mean each of our brains is wired a little differently?
Now you're getting to the heart of it. It's like each neuron has its own personality, its own way of responding to information. And to understand these personalities, neuroscientists use something called 5E curves.
5E curves. That sounds intense. Are we talking about giving brain cells personality tests now?
Not quite. Think of an IV curve like a neuron's personal response chart.
Okay.
Some are easily excitable, firing off signals with the slightest input. Those are the life of the party types. Others are more laid back, needing a stronger push to get going.
So some neurons are always ready to party, while others need a little more convincing. I can definitely see that in my own life. But how does this connect back to the idea of efficient information processing?
Well, this study discovered a fascinating link between the shape of these IV curves and something called the Ake current. You can think of the Ake current like upgrading to a faster processor in your computer.
Okay, now we're talking my language. So some neurons come equipped with a better internet connection, AD, a faster processor. That seems a little unfair.
It's not about being better or worse, but rather about the diversity of functions within our brains. And this research suggests that those with a stronger H current are better at transferring information, contributing to a more efficient system overall.
So even though our neurons have different personalities, they're all working together towards a common goal. That's actually kind of beautiful when you think about it.
It really is. And here's where it gets even more interesting. This study found that those chatty, excitatory neurons, remember them?
Yeah.
They showed a lot more variability in their IV curves compared to the inhibitory neurons.
So the inhibitory neurons, the ones with the noise-canceling headphones, are more consistent in their responses, while the excitatory ones are the wild cards. What does that tell us about how our brains work?
Well, it could explain why we each experience the world in our own unique way.
Yeah.
Imagine those excitatory neurons as the source of our individual quirks and perspectives, shaping how we learn, perceive, and even create.
Hold on, are you saying that my love for collecting vintage teacups could be linked to the unique shape of certain excitatory neurons in my brain? That's both fascinating and a little scary.
It's certainly a possibility. And it speaks to the incredible complexity and individuality of our brains. It's like each of us has a unique neural fingerprint shaped by the specific characteristics of our neurons.
Neural fingerprints. That's a pretty amazing concept. So even though we're all wired with the same basic components, the way they interact creates this incredible tapestry of individual thought and experience. But if our brains are so unique, how did the researchers even begin to study this on a larger scale?
That's the beauty of their approach. They weren't just looking at individual neuron personalities, they were looking at the bigger picture, analyzing the diversity within entire populations of neurons.
So like understanding the dynamics of a team, not just the skills of individual players.
Exactly. They were interested in how this variability, especially in those excitatory neurons, might contribute to differences in information processing across individuals.
This is getting really interesting. So not only do we have different types of neurons, but each type also has its own range of individual personalities. It's like our brains are even more unique than we ever imagined. But what does this actually mean for us in the real world? What can we do with this knowledge? So we're all walking around with these unique neural fingerprints shaping our every thought and experience. That's pretty profound when you think about it. But how does this research actually translate into something, meaningful for us? Can we use this knowledge to upgrade our brains?
That's the million-dollar question, isn't it? And while we're not quite at the brain hacking stage just yet, this research opens up some really exciting possibilities. For example, imagine being able to tailor educational approaches based on an individual's neural learning style.
Okay.
Yeah.
Okay, now that would be revolutionary. No more one-size-fits-all education. We could finally play to our strengths.
Exactly. Or think about the potential for personalized medicine, especially in treating neurological disorders. If we can understand what's going wrong at the neural level, we can develop more targeted and effective interventions.
So instead of treating a condition like Alzheimer's with a kind of broad stroke approach, we could potentially develop personalized treatments based on an individual's unique brain wiring. That could be a game changer for so many people.
Absolutely. But even beyond these practical applications, I think the real takeaway here is a sense of awe at the sheer complexity and beauty of the brain. We often take our cognitive abilities for granted, but this research reminds us that even the simplest thought or perception is the result of this incredible symphony of neural activity.
It really puts things into perspective, doesn't it? Just the fact that we're even able to have this conversation right now is a testament to the incredible power of our brains.
Precisely. And the most exciting part is that we're only just beginning to scratch the surface of understanding this vast and intricate world within our own minds.
Well, I don't know about you, but I'm feeling a whole new level of respect for the 3 pounds of gray matter between my ears. This has been an incredible deep dive into the world of neuroscience. We've gone from understanding how our brains filter out information overload to exploring the concept of neural fingerprints, and even touched on the potential for personalized medicine. It's amazing how much we're still discovering about the universe within our own minds.
And that's the beauty of science, isn't it? There's always more to learn, more to explore, more to understand.
Absolutely. So, to our listeners out there, keep those beautiful brains of yours buzzing with curiosity. And who knows, maybe one day you'll be the one making groundbreaking discoveries in the world of neuroscience. Until next time, keep exploring, keep learning, and remember, you're capable of amazing things.